Hi guys, this video we're going to actually go backwards a little bit in the textbook, which is fine. We're going to do solving absolute value equations. In your notes, you can absolutely put this after section 2.4. That's what I planned on. So that's what I would do. Oh, over here. So we're going to start with some properties of absolute value. So if you recall that when you take an absolute value of a number, any number, it means that it's positive. So you basically take whatever value is in there, it becomes positive. So it's going to be greater than or equal to 0. So for example, the absolute value of 3 is 3, and the absolute value of -3 is also 3. So absolute value fundamentally represents a distance. And we always express a distance in a positive value or as a positive value. A couple other properties. And I mean, that you can kind of see this again, this is A. So the absolute value of -3 is equal to the absolute value of 3. So those two things are going to be equal to each other. And if we have two numbers multiplied inside of an absolute value, you can essentially separate them and multiply them. Those are also equal. So if we had like 3 times 2 in here, that's equal to the absolute value of 3 times the absolute value of 2. The last property is a division property. So if we have the absolute value of A over B, that's equal to the absolute value of A over the absolute value of B. Okay, so those are our properties. So this is the first one. This is the second one. This is the third one, and this is the fourth one. Okay. So we also have, and I'll go into more detail about this when I come back. Okay, so this is going to be kind of our fundamental idea that we're going to be working with. Oh, that should be B. Sorry, not C. Equals C. And we can basically, when C is greater than or equal to 0, we can write these two linear equations. So the way that I do this is I view this as I'm breaking the bars apart. Okay, so the first one is going to be AX plus B equals C, and AX plus B equals -C. This will make more sense when we put actual values to A, B, and C, but just trust me for now. Again, I'll talk about this in more detail when I come back, why this works the way that it works. But these are the two equations. We basically come up with two linear equations when we split up an absolute value equation, typically. So let's look at the first example. I'll just put on this page right here. Example 1A. We're going to solve the absolute value of x minus 4 equals 6. Okay, so based off of this property, we can write two linear equations. So I'm going to break apart the bars. And so when we write our new equations, they're no longer there. So we have x minus 4 equals positive 6 and x minus 4 equals -6. Those are the two equations. Then we solve each of them. So x equals 10 and add 4 and x equals -2. So if we go back and just verify that this works, if we plug in 10 for x, we get 10 minus 4 inside the absolute value. The absolute value of 6 is 6. If we plug in -2, -2 minus 4 is -6 inside the absolute value. When you take the absolute value, it equals 6. So these are our two solutions. Next one. So still example 1, but example 1b. We're going to try to find the absolute value of 3x plus 1 equals -5. So one thing that I want you to remember is that, again, absolute value represents a distance. When we take the absolute value of a number, it should be positive. And that's we'll see more examples of this later, but that's if the absolute value is alone. So the absolute value is alone in example A. This number on the right, on the opposite side, is positive. This number over here, though, is negative. So if you think about what values for x could work, there are no values for x, either positive or negative or zero, that when you take the absolute value of it, it's going to equal a negative value or a negative distance. So this one actually is no solution. This can be kind of tricky to catch when you're practicing on your own. A lot of students will write the two equations using 5 and -5, but that's not right. It's no solution.